This week we are continuing our lessons in trig, and we're going to build on what we already know about the unit circle from what we learned last week. But before we do that, we need to learn some new words. And the main term that we're going to be talking about this week is radian. So when I talk about radians, radians are another unit of measure of an angle. So an angle can be measured in degrees, or it can also be measured in radians. So today we're going to learn how to go back and forth between degrees and radians, and we're going to learn what a radian is. So the first term we need to talk about is a central angle. And you should have learned about this in geometry last year, but a central angle is just an angle that has a vertex at the center of the circle. So an angle that has a vertex at the center of a circle, which is what we did all of last week. All of the angles we talked about were central angles. So a central angle is an angle whose vertex is at the center of the circle. So here's a circle, here's the center of my circle, and then I'm going to draw an angle with its initial side here and its terminal side here. And as you can see, that angle theta is a central angle because its vertex, where the terminal side and the initial side meet, is in fact at the center of the circle. Then we also need to talk about an intercepted arc. So as you can see, this angle that I drew, if I extend the rays of these angles here, okay, it intersects the circle, and it intersects the circle at this point and this point. Now, an intercepted arc then is the part of the circle that's between those 2 points of intersection. So like this would be an intercepted arc, that blue part of the circle I just drew in. So an intercepted arc is the portion of the circle with endpoints on the sides of a central angle. So the portion of the circle with endpoints on the sides of the central angle So as you can see, this intercepted arc here has endpoints where it ends here and here. These two endpoints are where the rays of that central angle meet the circle itself. Of the central angle and remaining points within the interior of the angle. So the remaining points of the intercepted arc are within the interior of the angle. And that just means that we're using this portion of the circle that's between the terminal side and the initial side of the angle, and not the outer part, the exterior of the angle, right? The intercepted arc is this portion, the interior of the angle. Before we talk about the actual definition of a radian, I'm going to show you what a radian is using a picture. So if you go down to these two circles, in the first circle, I just wanted to draw an example of an intercepted arc. So here is the center of my circle. If we draw an angle, a central angle, so the central angle has a vertex with the center of the circle, and then the intercepted arc is the portion of the circle between the two sides of the angle, the interior of the angle here. So this is an example of an intercepted arc. Okay, then the other circle I wanted to use to explain what a radian is. So we're going to go ahead and add the center of the circle. So 1 radian actually occurs when the radius of the circle is the same distance as an intercepted arc. So let me draw a picture of what that means. So for example, if I had the terminal side of an angle here, this distance from the center of the circle to the side of the circle is our radius, right? That's our radius. So if I create a central angle that has an intercepted arc that's the exact same distance as that radius, that creates an angle that is 1 radian. So if I have a central angle, so I'm going to draw the other side of my central angle here. And if that central angle creates, I'm going to use a highlighter, an intercepted arc that's the exact same distance as your radius, you've created an angle that is 1 radian. So if this distance, this intercepted arc, is the exact same distance as the radius, so these two distances are the same, you've created an angle that is 1 radian. So I'm going to use a different color for that. Let me use red. This angle would be 1 radian. So that means that the definition of a radian is the measure of a central angle that intercepts an arc with length equal to the radius of the circle. So the measure of a central angle that intercepts an arc with length equal to the radius. So if you've created a central angle that has an intercepted arc that's the same as the radius, the same distance as the radius, you've created an angle that is exactly 1 radian. So this is just like the backstory of a radian. Where do radians come from? This is where they come from. So the measure of a central angle that intercepts an arc with length equal to the radius of the circle. So radians are like degrees. They measure the amount of rotation from the initial side of an angle to the terminal side. So a radian measures the amount of rotation from the initial side to the terminal side, just like how we measure an angle in degrees. We're still measuring the rotation of the angle, and we're still measuring essentially the angle, right? But instead of talking about it in degrees, we're talking about it in radians. So let's just make a note of that for ourselves. So radians are like degrees, measure the amount of rotation from the initial side of the to the terminal side of an angle. The amount of rotation from the initial side to the terminal side of an angle. So that's what a radian is. It's just another measure of an angle. Instead of in degrees, it's in radians. So let's talk some things that we already know. So just like we know that there are exactly 360 degrees rotation in a circle, we can also figure out some things about radians. So a radian is based on the length of an intercepted arc. So for example, if we wanted to find the radian measure of an angle of an intercepted arc where here's my initial side, and then I rotate 360 degrees, what is the length of this intercepted arc? The length of this intercepted arc would be the entire circumference of that circle, right? Well, the circumference of that circle is equal to 2 pi times the radius, which means that the whole circle contains 2 pi radians. So the measure of that angle in radians would actually be 2 pi. So instead of talking about that angle, the rotation in terms of 360 degrees, we can say that the rotation is 2 pi radians. Well, if an entire circle has 2 pi radians, then how many radians would just half of the circle be? So we're going to take our 2 pi and we're going to divide it by 2. Well, 2 divided by 2 is 2, so that means that half of the circle has exactly 1 pi radians, or pi radians. So since 2 pi radians is the same thing as 360 degrees, then it follows that 1 pi radian, so just a single pi radian, would be equal to 180 degrees, exactly half of that. Since we can go back and forth between radians and degrees, we need to be able to represent the same angle measure in either radian or degrees. So if I want to convert degrees to radians, all I have to do is take the degree measure of my angle and multiply it by pi radians over 180 degrees. And we know that this will work because half of a circle has pi radians and half of a circle has 180 degrees. So then the reverse of that would be to go from radians to degrees. So then we would take our radian measure and simply multiply that by 180 degrees over pi radians. And we'll talk about how this works in just a second with our examples below. So now we're going to convert all of these degree angle measures to radians. So we're going to use our formula, degrees times pi radians over 180 degrees. So all I have to do is take my 27 degrees and multiply it by pi radians over 180 degrees. So what happens when I divide something by itself? It cancels, right? So if I divide degrees by degrees, it cancels. So we're going to be left with radians. So I'm going to have 27 times pi, so 27 pi. And technically, isn't 27 degrees over 1? So then I'm just multiplying 1 by 180. So 27 pi over 180. So 27 degrees is 27 pi over 180 radians. But we need to simplify this just like we would any other fraction. So I know that 9 goes into 27 and 180. So if I take 27 divided by 9, I'm going to get 3. And if I take 180 divided by 9, I'm going to get 20. So this reduces to 3 pi over 20 radians. And when we talk about radians, we do want to leave them in terms of pi. Unless you're specifically asked to, you're never going to write them in as a decimal. We do want to consider radians in terms of pi. So it's okay to leave it as a fraction. It's okay to leave it with pi in there. Unless you're asked to convert it to a decimal, don't. So why don't you go ahead and convert 90 degrees and negative 225 degrees into radians. Press pause on the video and then press play when you're ready to check your answers. Let's go ahead and convert 90 degrees. So we're going to take our 90 degrees and we're going to multiply it by pi radians over 180 degrees. So we know that degrees divided by degrees cancels. I'm going to be left with radians in my final answer. I'm going to take 90 times pi over, and then 90 is technically over 1, so 1 times 180. But then we can simplify this fraction. So 90 divided by 90 is 1. 180 divided by 90 is 2. So this simplifies to 1 pi, or just pi over 2 radians. So 90 degrees is the same thing as pi over 2 radians. Now for negative 225 degrees. So we're taking negative 225 degrees times pi radians over 180 degrees. Again, we're dividing degrees by degrees, so they cancel. Negative 225 times pi is negative 225 pi over 180. And we're left with radians. Then we need to simplify this as much as possible. So 225 and 180 can both be divisible by 5. If I divide this by 5, I'll be left with 45. If I divide 180 by 5, I'm left with 36. So we'll have negative 45 pi over 36 radians. 45 and 36 are both divisible by 9. This will be 5, and this will be 4. So we'll have negative 5 pi over 4 radians. So just like an angle measure in degrees can be negative, so can radians. That just means that instead of rotating counterclockwise, they rotated clockwise. So remember, counterclockwise gives us a positive angle measure, counterclockwise gives us a negative angle measure. It's just like that with radians. So now let's do the opposite. Let's convert some radians to degrees. So I'm going to scroll up for just a second. And when I want to convert radians to degrees, I multiply my radians by 180 over pi radians. So all they did was they flipped the second part. Because we want to take radians divided by radians, because that will cancel, and then we'll be left with degrees as our unit measure. So we're going to take our negative 3 pi over 4 radians, and we're going to multiply it by 180 degrees over pi radians. So some handy dandy stuff happens here. Because radians divided by radians cancels, pi divided by pi cancels, and then we're left to multiply just like the integers. So negative 3 times 180 is negative 540. And then 4, there's nothing left to multiply here. Technically, there's a 1 now, right? So 4 times 1 would be 4, and then we have degrees. And can 540 be divided by 4? It sure can. This is negative 135 degrees. So negative 3 pi over 4 radians is the same thing as negative 135 degrees. So that angle of negative 135 degrees is the same thing as negative 3 pi over 4. Those two radians, sorry. Those two units of measure this exact same and represent this exact same angle theta with a clockwise rotation because it's negative. Why don't you go ahead and press pause, do B and C on your own, and then press play when you're ready to check your answers. So for part B, you should have taken 3 pi over 2 radians times 180 degrees over pi radians. Well, what happens when radians divide radians? They cancel. Pi divided by pi cancels. And then before we even multiply, we can reduce if we want. So I know that 2 divided by 2 is 1. 180 divided by 2 is 90. So then 3 times 90 degrees would be 270 degrees over 1 times 1 is 1. 270 divided by 1 is just 270. So 3 pi over 2 radians is the same thing as 270 degrees. Now let's convert 7 pi over 6 radians to degrees. So 7 pi over 6 radians times 180 degrees over pi radians. Again, radians divided by radians cancels. Pi divided by pi cancels. How nice of it. I can reduce 180 by 6, so 6 divided by 6 is 1. 180 divided by 6 is 30. 7 times 30 would be 210 degrees, and then it'll just be over 1 because everything in the denominator canceled, so we don't need to worry about our denominator. So 210 degrees is our final answer.